Good morning. We will start session 1 on chapter polynomials. So this is the first chapter on mathematics what we are starting. So whatever is written on the board, let that be definition or exercise. You have to meanwhile pause the video wherever required and copy down the sums. I will be giving some homework sums also. So you need to solve that so that in the next session I will discuss the answers of the homework sum and then I will proceed with the next exercise. Another most important thing is I want you all to watch the video on the same day of the video sent, so that if you have any doubt in the concept what I teach on that day, you can call and confirm and clarify your doubts, so that in case if you have any doubts, I can address those doubts in the next day's session before I actually start with the exercise. So later if you ask the doubt once the chapter is over, it will be difficult for me to address the doubt. So I request you all to watch the video on the same day of the video set. So here we start with the chapter polynomials. This is a continuation of the chapter, what I can say, what you have studied in 9th standard. You had in 9th standard polynomials in one variable, where the introduction, what is a polynomial, types of polynomial, zeros of polynomial you have studied. Let's just quickly brush up the introduction of the polynomial. Polynomials in one variable x is an algebraic expression of the form an x raised to n, n minus 1 to x raised to n minus 1, so on to ax square plus ax plus a to the base 0, where a to the base n minus 1, a to the base 2, a to the base 1 and a to the base 0 are nothing but constants, where x is the variable. Also, these constants are also called the coefficients of the polynomial, which you have already studied in standard 9. We have also known that the highest exponent in a polynomial is known as its degree. So we identify the polynomial by its degree. The highest the degree, that is the polynomial. So the highest exponent in the polynomial is known by its degree. So whatever is the degree, highest degree, with that we identify the polynomial. Types of polynomials, we have linear, quadratic, cubic and biquadratic. Linear polynomial, a polynomial of degree 1 is called as a linear polynomial. I have just given a few examples: 3x plus 5, 5z, etc. It is of the standard form ax plus b, where a not equal to 0. Because if a is 0, then x term also will be 0. It will be only a constant, right? Similarly, we have a quadratic polynomial. A polynomial of degree 2 is called as a quadratic polynomial. Few examples. It is of the form ax square plus bx plus c and a not equal to 0. Then we have a cubic polynomial. A polynomial of degree 3 is said to be a cubic polynomial. So see here, highest degree is 3, highest degree is 2, highest degree is 1. It is of the form ax cube plus bx square plus cx plus d, where again a not equal to 0. And the last one, that is biquadratic polynomial. A polynomial of degree 4 is called as a biquadratic polynomial. It is of the form ax raised to 4 bx cube plus cx square plus dx plus e, again a not equal to 0. So this is a brief introduction about the chapter polynomials. I want you all to write down as I have written down on the board point wise in your book. So we also know about zeros of a polynomial. A real number k is said to be a zero of a polynomial f of x if f of k is 0. That is, a zero of a polynomial is number of solution to the given polynomial. That is, a linear polynomial will have only one zero, that is solution. A quadratic polynomial will have 2 zeros. A cubic polynomial will have 3 zeros and a biquadratic polynomial will have 4 zeros, right? So this is something new. Till here this was the how geometrically we can represent and how graphically we can understand, or we can read this, or we can understand how many zeros a polynomial has based on the graphical representation. Let's understand. For any quadratic polynomial, yes, moreover in this chapter we'll be dealing with a quadratic polynomial. For any quadratic polynomial, ax square plus bx plus c, where a not equal to 0, the graph of the corresponding equation, when we write it in terms of a y-intercept, that is y is equal to ax square plus bx plus c. We equate the whole quadratic polynomial in terms of y, so that we can see, for a graph you require x-axis as well as y-axis, so that I can give the value for x and I can find the value for y here. So this will be equated to y is equal to ax square plus bx plus c. You have this graphical representation later in quadratic equation chapter. In linear equation chapter. We'll be studying that later. So here we only have the representation where you need not draw anything in the graph book. So the corresponding equation equates to y is equal to ax square plus bx plus c. That means the zeros of the polynomial p of x are precisely the x coordinate of the point where the graph y is equal to p of x is nothing but this, intersects the x-axis. Now simple terms if I have to tell you is, whatever graph you draw against this, that is with respect to this, by plotting x and y value, the graph which cuts on the x-axis is the zero of the polynomial. That is the meaning of this. The graph when we draw for a quadratic polynomial y is equal to ax square plus bx plus c is in sometimes this form, or it is this form, which is called as a parabola. So you again study this in the linear equation later, right? So here we'll understand just briefly about it. So this parabola, that is a graph when it is cutting. So on x-axis precisely when it will cut, that is nothing but the point where it cuts is counted as the zero of the polynomial. Now look at this graph. I have just drawn several graphs here. Now let us see where is the graph cutting on x-axis. So which all point it cuts, those many zeros the part will have, polynomial will have. The first one, if you can see, it is cutting on x-axis at only one point. That means this particular polynomial after plotting has only one zero, right? Look at this graph. It is cutting x-axis at two coordinates, right? That means this polynomial, when we represent this quadratic polynomial, has two zeros. Look at this, where it is cutting at 1, 2 and 3 points. That means it has 3 zeros. Look at this one, it is only cutting at 1 point, that is it has 1 zero. What about this graph? This is a linear graph. So linear graph will cut at x-axis at one single point, then it has only 1 zero. Now suppose if you draw a graph like this and this is the parabola, you get it. So how many zeros does the quadratic polynomial has? 0. Why? Because the graph or the parabola is not cutting on the x-axis. That is one thing. Another way, if I draw it like this, how many zeros does this graphical representation have? It has 0 because it is not cutting on the x-axis. Precisely understand that it has to cut on the x-axis. So the x coordinate of the point where the graph of y is equal to px intersect the x-axis, those number of zeros will exist for the given quadratic polynomial. We only have one exercise on this graphical representation wherein we can just see the graph and we can identify the number of zeros. These questions are usually asked for 1 mark and MCQs. Now, the next major concept and the important concept of the of a quadratic polynomial. We know what are zeros, what are coefficients of quadratic polynomial. So if I consider, let alpha and beta be the zeros of quadratic polynomial. Why alpha and beta? It can be capital A, capital B, it can be M and N, it can be X and Y, anything. So here they have given it as we term those zeros as alpha and beta. Let's address them as alpha and beta. Let alpha and beta be the zeros of the quadratic polynomial ax square plus bx plus c where a not equal to 0. That means if alpha and beta are the zeros of the given polynomial, can I consider x minus alpha and x minus beta are the factors of p of x? Right? So if you can just remember, I'll just get my duster. Yeah, I have actually cleared this part, but you can in between anytime you can pause the video and write down this content. First and foremost, you have to write down the first part, what introduction I gave, polynomials, types of polynomials, linear, quadratic, cubic and biquadratic. Then zeros of a polynomial definition, what I had written there. After that I had written graphical representation, how we represent zero of a polynomial. You can pause at that particular time and write it down. Okay. So next is that's what I was telling, relationship between zeros and coefficient. So let alpha and beta be the zeros of the quadratic polynomial. This is a polynomial. That means x minus alpha and x minus beta are the factors. If I tell you this is a quadratic polynomial, say as p of x, just I will write minus 3x plus 2. I've just written it 1. That means if I tell you, if I give some values for this, I'm just giving random numbers, not accurate one. So I will, after solving this by splitting the middle term, I will get the answer as x is equal to 1 and x is equal to minus 1 are the zeros of the polynomial I will get. That means, can I tell x, and take this as 2, x minus 1 and x minus 2 are the factors of this? If you can just recall what you had in 9th standard. If the given terms are the zeros of the given polynomial, then they are the factors. If they are the factors of the given polynomial, then the remainder is 0. Yes, you can recall that. So whatever are the zeros, if I write x is equal to 1, find the 0 of the polynomial. What did you do? X minus 1 equated to 0, x is equal to 1. Yes, you can recall that. Yes, the same principle I have used here. Therefore, if alpha and beta are the zeros of the quadratic polynomial, that means x minus alpha and x minus beta are the factors of p of x. Okay. Next, how do we represent sum of zeros and how do we represent product of zeros? That is why it is relation between zeros and coefficient. Sum of the zeros is given by minus coefficient of x divided by coefficient of x square. This is a standard. You also have a derivation, but we are not doing derivation as it is not a syllabus point of view. So we only have to know the relationship between, not the derivation. Sum of the zeros is equal to minus coefficient of x upon coefficient of x square. Now what are the sum of the zeros? Alpha plus beta. Sum is equal to minus coefficient of x. What is coefficient of x here? B. Minus b. Coefficient of x square? A. Minus b by a is the standard form of sum of the zeros. Sum of the zeros of a given quadratic polynomial is given by minus b by a. What is that b? Coefficient of x. What is that a? Coefficient of x square. Then product of zeros is given by constant term divided by coefficient of x square. Constant term here is c. Alpha beta is equal to c by a. So this sum and product of 0 will stand only for a quadratic polynomial. If in case you have a cubic polynomial, the sum and the product are different. Now cubic polynomial will not come in your syllabus, though they have given in worked examples, but still you do not have cubic polynomial in your syllabus. We can do that later as an extra sums point of view, but as of now what is there in your book, we only stick to that. So this is sum of the zeros and product of the zeros. There's one more important thing. From sum and product of the zeros, what we have to write is the standard form. The standard form of quadratic polynomial is, how do we write a quadratic polynomial? That is, it's nothing but x square minus sum of zeros of x plus product of zeros. What does this mean? It is written as x square minus alpha plus beta of x plus alpha beta. I am going to put this in a box. I expect you all also to do the same thing. It's very, very important. Now what is this? Whatever quadratic equation I write, I just write a quadratic equation here. Assume that this is a quadratic equation. What term I have got here? This is nothing but sum of the zeros. When I add the zeros of the given polynomial, I get this. When I multiply the zeros, what I have got, I get this. So this quadratic polynomial is of this form. We have examples how to frame and how to write. You will understand. But this formula you need to remember. The standard form of quadratic polynomial is x square minus sum of, always it is minus. Why? If this term is minus, then that will become plus. That's the standard form how we write it. So now I want you all to write first the polynomials introduction what I have given. Next, zeros of polynomial, graphical representation which I have already erased, but you can anytime pause and write that. Relationship between zeros and coefficients of quadratic polynomial. See, make a point wherever I have put it in a box, it's very important. Please highlight that. It's just to understand. Then this, right? After this, we'll start with the exercise. Yes, I'll be only orally discussing the first exercise, which is nothing but the graphical representation. That's a very small exercise here. They have already given you the graph. You need to only write the number of zeros. Though it is only marking, I still want you all to write this in a book. This graphical representation, just a small rough diagram can be drawn. Write this in your book and write number of zeros against it, right? So, for the first one, if you can see, there is, I want you to keep a textbook in front of you so that it will be easy for you to understand what I am reading it out. For the first one, that is this one here, the graph is not cutting on x-axis. So, how many zeros it has? It has 0, correct? For the second one, it is cutting at x-axis at only 1 point. If you can see, it is cutting here, right? So, number of zeros are 1. Zeros is 1. For the third one, count how many zeros? 1, 2 and 3. So, there are 3 zeros. For the fourth one, it is again cutting at 2 points. So, there are 2 zeros. I need not write on the board because I think it is very simple to understand. You all have understood the graphical representation in that how to count the zeros, right? So, fifth one, count the zeros. 1, 2, 3, 4. That means in x-axis to the left hand side there are 2 points, right hand side there are 2 points where it is cutting. Last one, that is sixth one, count the zeros. 1, 2 and 3. There are 3 points. Quite very simple. As I have told, it will be only asked for MCQs. But still, I want you all to draw this graph in your book and write the number of zeros against it. So now, we'll begin with the actual exercise. The first exercise is very small. So there are only 2 mains in it which we will be completing it today. Now our mathematics sessions will go a bit longer than our science sessions. So moreover, the classes might be for 40 to 45 minutes. That means I'll be completing at least one exercise in a session. Depending on the exercise, if the exercise is too big, I'll be cutting it short. Otherwise, it will be one exercise. So 40 to 45 minutes will be the minimal time what I'll be teaching. So the first one, find the zeros of the following quadratic polynomial and verify the relationship between the zeros and the coefficient. So before we verify the zeros, we need to find the zeros of the quadratic polynomial. Now how do you find the zeros of the quadratic polynomial? Factorization method, splitting the middle term. Now that's what I told you. This is a continuation of the polynomial chapter what you studied in 9th standard. It's same continuation here. So before I actually start with the sums, I will mark the homework sums. Please make a note. So in first main, first one will be your homework, then third one, okay, second one also you can take it as simple. Second one will be the homework and sixth one will be the homework. Okay, remaining third, fourth and fifth I'll solve here. I have written here first main, first, second and sixth one is the homework. So tomorrow's session when I start, I will discuss the answers of these sums which you have given for homework. Then we will begin. So I will start with the second sum now, which is 4s square minus 4s plus 1. Now looking at this, I know this is a perfect square. It is in the form of a minus b whole square, but still we will factorize it and we will solve it. Again, it's up to you. Usual factorization method, what we do here is we always multiply first and last term. That's the rule. So what do you get? 4s square. So try to write the maximum factors of 4s square, whatever you do. So how do we get? 4s into 1s. Both are plus is 4s square. Otherwise 2s into 2s will also give you 4s. Now here, when you multiply you get this. When you add or subtract also you have to get this. Now in both the case we are getting 4s square. But I want here when I add them or when I subtract them I have to get minus 4s. Wherein this case is not possible and this is possible. 2 plus 2 will give you 4. But I want here minus 4. So that will be minus 2s and minus 2s. Minus 2s will give me minus 4s. Minus 2s into minus 2s minus plus I get 4s square. That's the way how we do factorization. I could have directly taken a minus b whole square and I would have done, but I wanted to show you on the factorization rule so that you can apply that for first, second and sixth one. Right? So whatever are the factors, let us use it here. So 4s square minus 2s plus 1. So try to take common always. Between this what is common? 2s is common. So 2 2s are 4. 2s into 2s is 4s square minus 1. Remember one thing, whatever you write here in the bracket, the second bracket will always be the same. So without doing anything, write off the second bracket. Okay? Then check what you want here. 2s into what should give you minus 2s? It should be minus 1. Minus 1 into minus 1 plus 1. Automatically it comes. So whatever you write here, write it off. That's a rule of factorization. Now club them. 2s minus 1 and 2s minus 1. Right? Now 2s minus 1 and 2s minus 1 are the factors of these terms. Right? So the zeros of 4s square minus 4s plus 1 is equal to, if you want to find the 0, we have to equate the equation whatever you have got to 0. That is 2s minus 1 equal to 0. It is going to be the same thing, but you have to do that twice. It's been the same, and just write here, or once again 2s minus 1 equal to 0. So 2s is equal to plus 1, s is equal to 1 by 2, and s is equal to 1 by 2. That's correct. What we have got, did you understand here? Since s is equal to 1 by 2 and 1 by 2, they are the same because it's an identity. It has to be. Let alpha is equal to 1 by 2, beta is equal to 1 by 2. Now assume that you got one as 1 by 2 and another one is 3 by 2. Anything can be alpha, anything can be beta. It's up to you to choose that. Since we have got now zeros of the given polynomial. Now what is our thing? Now we have to verify the relation between zeros and the coefficient. This has to go in these steps only. Very neatly, each and every step is important. Now here I do not have space down, so I will be doing it beside this. I expect you all to do it one below the other. It looks very neat. So I will write here verification. Okay, so for verification, I again write the polynomial what I have, 4s square minus 4s plus 1, which is of the form ax square plus bx plus c. Correct? It is of the same form. Write down the coefficients. A is equal to 4, then b is equal to minus 4, c is equal to 1. Okay. Sum of the zeros will directly apply. Alpha plus beta. What's the formula? Minus b by a. Let's substitute. Let us substitute simultaneously. What is alpha value? 1 by 2. What is beta value? Also 1 by 2. Is equal to. What is b by a? Minus is in the formula. Let the minus be as it is. Bracket. B is also minus. Minus 4 upon 4. Half plus half. Do not take LCM again. Half plus half is 1. Is equal to. So minus minus plus 4 and 4. 1. Verified. Sum of the zeros are verified. Let's check with the product of the zeros. Alpha beta is equal to c by a. Correct? So what is alpha? 1 by 2. Beta into 1 by 2. What is C? 1. What is A? 4. 1 by 2 into 1 by 2 is 1 by 4 is equal to 1 by 4. So this is how you have to solve the sum. So with all the steps, first factorize it for all these three what I have given. Once you factorize, you get the factors. Find the zeros by equating it the factors to 0. You get two values. So term anything as alpha and anything as beta. Stick to that alpha and beta. Verification, write the equation once again. Equate that to ax square plus bx plus c. Write what is a, b, c, its coefficients. Sum of the zeros, b by a. Substitute along with the zeros. Product of the zeros, substitute along with the zeros. It has to be the same. That's a verification. Right? So I want you all to copy down this. I'll start the next one. Yeah, children, small correction. The homework sums are first one, second one I have already done it. So this has to be third one, right? First one, third one and sixth one. The second one I have already done. So these three are the homework sums. Please do the necessary corrections. So we'll start with fourth one, that is 4u square plus 8u. Now here you need not go for factorization because we only have two terms here. So what we will do here is I will take 4u common. 4u into u will give me 4u square plus 2. Right? So since it's a quadratic polynomial where the terms given, it should have two zeros. That means I will write here the zeros of 4u square plus 8u are, I will equate 4u is equal to 0, where u is equal to 0 is one thing, and u plus 2 is equal to 0 when u is equal to minus 2. This means let alpha is equal to 0 and beta is equal to minus 2. So let's go for verification now quickly. Verification. So in verification, first I need to write the polynomial 4u square plus 8u. This implies ax square plus cx, ax square plus bx plus c, where your a is equal to 4, b is equal to 8 and c is equal to 0, because there is no constant term here. Let's verify quickly. Sum of these zeros, alpha plus beta is equal to minus b by a. Sum of these zeros. What is your alpha here? 0. What is your beta here? Minus 2. So shall I write directly minus 2? Okay. Minus in the formula, b is 8 where a is 4. Minus 2 is equal to 4 ones are 4 twos are minus 2. Verified? Yes. Let's go for product of the zeros. Product of the zeros is equal to c by a. So alpha is 0 into minus 2 is equal to c. C is 0 upon a is 4, which is nothing but 0 is equal to 0. Hence verified. This is how we verify it. The last one in this main, that is fifth one. T square minus 15. It is a quadratic polynomial. Again here x term is not there, but the constant is given. So how do we write it? We can directly say the zeros of polynomial or zeros of t square minus 15 are. So I will write here t square minus 15, equate the equation to 0. T square is equal to 15, right? T is equal to square root of 15. So when we write square root of 15, when we are equating it, that comes plus or minus, because every root has two, that is two signs. One is plus and one is minus. So t is equal to plus or minus root of 15, square root of 15. So I will write let alpha is equal to root 15 and beta is equal to minus root 15. Can I write this? One is plus, because every root has two signs. One is plus and one is minus. You have plotted the root numbers on the number line in 9th standard, right? Plot root 2 on number line. It can be also plotted on minus sign, that is left hand side on the negative axis, as well as right hand side on the negative axis. Let's go for the verification quickly. Verification. So I'll write the polynomial once again. T square minus 15, which is of the form ax square plus bx plus c, where a is 1, b is 0 and c is minus 15, right? Okay. Sum of the zeros, alpha plus beta is equal to minus b by a. What is alpha? Root 15. What is beta? Minus root 15. What is b? 0 by 1. Plus 15 minus 15 will get cancelled. 0 is equal to 0. Verified? Let's go for the next verification. Product of the roots, alpha beta is equal to c by a. So we have alpha as root 15 into beta as minus root 15 is equal to c. C is given as minus 15 15 by 1. Square root into square root, or 15 15s is square root of 225. Root 225 is nothing but 15 again. Or when we multiply two square roots, they get cancelled each other. That's because, see here, root 15 whole square, right? Square and root will get cancelled. Otherwise, root 15 into root 15, root 225. What is root 225? 15 again. Same thing. So, root 15 into root 15. Remember, minus sign is there. Minus 15 is equal to minus 15. Hence, verified. So, there we complete the first main. That is how we find the zeros and we verify with its coefficient. So, I want you to write down this, and remember, first one, third one and sixth one are marked for homework from the first main. We'll start with the second main. So, the second main and the last main for today's class. In the second main, find the quadratic polynomial each with a given number as the sum and the product of its zeros respectively. That means we have to frame a quadratic polynomial wherein they have given a sum and the product to us, wherein these are given. So we know how to frame because we know the standard form of a quadratic polynomial, how to frame it when sum and product are given. So here in this, fourth one, fifth one and sixth one, you will take that as a homework. I will be fourth one, fifth one and sixth one will be for homework. First, second, third, I will be doing it here. So let's start with the first one here. So they have given 1 by 4 and minus 1. That means they have given sum of the zeros and product of the zeros. Let me write it. Solution. Sum of zeros, that is alpha plus beta, is equal to 1 by 4. You need to write this. Now see, again these are asked for 1 mark question, but here we need to elaborate and write. Product of zeros, alpha beta is equal to minus 1. Now, can I take minus 1 as sum of 0 and 1 by 4 as product of 0? Can I do that? No. Why? The question given here is, they have given sum and product respectively, right? That means the first one is sum and the second one should be product. That you have to make a note of it. Okay, then write the standard form of quadratic polynomial is x square minus sum of the zeros of x plus product of the zeros. Just substitute in this, that's all. Keep x square as it is minus, what is sum of the zero? Minus 1 by 4 of x. What is product of the zeros? Minus 1. So directly I write minus 1 here. Minus 1. This is the answer. But always remember, we do not keep anything in fraction. In a quadratic polynomial, when we write, if it is a x square term or x term, we will not keep anything in fraction as a rule. So what we can do here is multiply the whole equation by 4. So the final answer will be 4x square minus x minus 4. Very clear? So let's start with the next one. So let's start with the next one, that is second one. They have given us as root 2 and 1 by 3. So I will not write again sum of zeros. I will directly write solution alpha plus beta is root 2 and alpha beta is 1 by 3. Next, the statement is compulsory. The standard form of quadratic polynomial is x square minus sum of the zeros of x plus product of the zeros. Substitute. X square minus sum of the zeros is what? Root 2x. Product of the zeros is 1 by 3. You want, you can keep it as it is. Otherwise, multiply the whole equation by 3. 3x square minus 3 root 2x plus 1 is the given equation. Clear? The last one, that is third one. What they have given? 0 and root 5. So, alpha plus beta is 0, alpha beta is root 5. I want you all to write this, the standard form of quadratic polynomial with this. Shall I only write the equation? But please write this, no shortcuts. Is x square minus alpha plus beta of x plus alpha beta. Please write this statement. Substitute. X square minus alpha plus beta is what? 0x. Alpha beta is what? Root 5. 0x, do you want to represent it? No. X square plus root 5 is the answer. That's all. Quite simple. So, this is how we represent a quadratic polynomial in an equation with respect to sum and product of zeros. With that, we complete the first exercise. Now, the next exercise is about the division algorithm of polynomials, which you have already done in 9th standard. That is, dividend is equal to divisor into quotient plus remainder, which we will be doing that in our tomorrow's session. So, in today's session, what I have taught, if you have any doubt, please call on the same day of the video sent, because it will be easy for me to address your doubt in the tomorrow's session before I actually start with the next concept. And the homework sums what I have given you all, please do it, so that I will discuss the answers of the homework sum in tomorrow's session before I start with the actual concept. So please call if you have any doubt on this session on the same day of the video set. Thank you.